Your browser is not the only thing worth intercepting. Here's the mindset shift for this episode. If an app talks to a server, you can sit in the middle of that conversation. Phone apps, desktop programs, API tools, all of it. In the next few minutes, I'll show you how to route everything through Burp, including the mobile apps on your phone, and what to do when an app fights back with certificate pinning. Let's get everything on the wire. Quick refresher, because it's the whole foundation. Burp works by being a proxy, a checkpoint in the middle. Traffic goes from the app to Burp to the server and back. Two things make that work. One, the app has to be told to send its traffic to Burp's address and port, usually your machine's IP on port 8080. And two, the app has to trust Burp's certificate. So HTTPS doesn't throw errors, which means installing Burp CA certificate on the device. Address plus certificate. Get those two right, and almost anything becomes interceptable. Let's start with the big one, mobile apps, because that's where a huge amount of modern attack surface lives, and it's where beginners get stuck. The goal is simple: make your phone send its traffic through Burp on your computer, so every request the app makes shows up in your HTTP history, just like a website. Here's the setup, step by step. First, put your phone and your computer on the same Wi-Fi network. In Burp, open the proxy listener settings and bind it to all interfaces, not just localhost, so your phone can reach it. Note your computer's IP address. Then on the phone, go into the Wi-Fi settings, edit the network, and set a manual proxy, your computer's IP, and the port 8080. Now the phone is pointing at Burp. But if you open an HTTPS app right now, it'll error because the phone doesn't trust Burp yet. So the second step, visit Burp's built-in address in the phone's browser, download its CA certificate and install it. Address, then certificate, the same two ingredients. With that done, open an app and watch Burp. Suddenly, its requests pour into your HTTP history, the API calls, the tokens, the endpoints, the app was quietly talking to. This is gold because mobile apps often trust their backend more than websites do, and they expose APIs that were never meant for you to see. Now you can send any of those requests to repeater and start testing exactly like the web. But sometimes you do all that and the app still refuses to connect or shows a network error. That's not a mistake on your end. That's certificate pinning fighting you. Pinning means the app was built to only trust one specific certificate, its own, and it flat out rejects Burps even though the phone trusts it. It's a defense against exactly what we're doing. Regular apps don't pin, but banking apps and anything security conscious often do. So how do you get past it? You bypass the pinning at runtime, and the go-to tool is called Frida with a friendly wrapper on top called objection. The idea: on a rooted Android or jailbroken iPhone, Frida injects into the running app and quietly disables the code that checks the certificate. With objection, it's almost one command, objection explore, then Android SS pinning disable and the pin just stops working. Suddenly the same app that blocked you is flowing into Burp. A heads up, this needs a rooted or jailbroken test device. Never do this on your daily phone or anyone else's, and only on apps you're allowed to test. Pinning bypass is powerful, and it's exactly the kind of thing that needs permission. Phones aren't the only non-browser target. Thick clients, desktop programs like a chat app or a game launcher also talk to servers, and you can proxy them too. If the app respects your operating system's proxy settings, just point the system proxy at Burp and you're in. If it ignores that, a tool like Proxifier can force its traffic through Burp anyway. And for apps that don't send a proper destination, Burp has an invisible proxying mode that handles it. The principle never changes: get the traffic to Burp, trust the certificate, intercept, finally, your own tools. When you're testing an API, you'll often use Postman or plain curl, and you can run those through Burp too, which is fantastic for keeping everything in one place. In Postman, open the settings and set the proxy to your Burp address and port. With curl, add -x pointing at Burp and -k so it trusts the certificate. Now every request you fire by hand is logged, editable and replayable in Burp, right alongside the app traffic. 4 things that save headaches. 1. Remember the 2 ingredients. Whenever something won't intercept, ask, is the traffic pointed at Burp? And does it trust the certificate? 2. Use a dedicated rooted or jailbroken test device for mobile, never your real one. 3. On newer Android, apps ignore user certificates by default, so a rooted device and the system store is a reliable path. And 4. If pinning blocks you, reach for objection before anything more complicated. Why does this matter? Because attackers don't stop at the browser, and neither should you. A staggering amount of sensitive functionality lives in mobile apps and desktop clients. Talking to EP is that nobody tests because nobody bothered to get them on the wire. The skill of proxying everything is what turns you from a website tester into someone who can look at any target. If it sends a request, you can read it, lock it in. Proxying anything is always two ingredients: point the traffic at Burp and trust Burp certificate. For mobile, set a Wi-Fi proxy and install the CA cert. If the app pins, bypass it with Frida and objection on a test device. Thick clients go through the system proxy or Proxifier, and your own tools, Postman and curl, route through Burp too. Screenshot this. That's proxying everything. Nothing an app does stays invisible to you. Next episode, we start automating, writing your first simple scripts in Bash and Python to do the boring, repetitive work for you so you can focus on the interesting bugs. Subscribe so you don't miss it, and tell me, what's the first app you want to intercept? See you in the next one.